Okay, so this is, I suppose, part 2 of the Tamiya Dynastorm runner build project. I've made some progress here on the gearbox portion of the build. There's really two pieces to this. There's the differential component, and then there's the slipper clutch component. So I'll start with the differential. My original plan was to try to put in a non-Dynastorm differential in here, because with the Dynastorm diff, the way that goes together is you essentially have two diff halves, right? If we go to, where the heck is it? I thought I had it. Oh, right here. So your diff outdrive is split into two pieces. You have the plate with the ring that goes on the inside that runs against the diff balls, and then you have an outdrive with a spline that mates to splines on the inside of this disc. And with all these older Tamiya cars, whether it's this or the Top Force or TA01, those kinds of cars, these spline setups are a point of failure, especially when you're putting a lot of power through the gearbox. Now, I only intend to run a silver can motor in this, at least for the time being, so I'm not too worried about running splines, but I was hoping that I could find a way to run a more conventional diff, like a Kyosho RT6 style diff, or to me make something very similar, like for the, I think the FD4, the new 2022 Astute car. They have a more conventional diff with a conventional diff half. The only problem with those types of units is the type of bearing you have to use. The thing with this Dynastorm gearbox is that the bearing that goes onto the diff half is an 8x12 bearing, because this diameter here of this part of the outdrive is 8 millimeters, and then the outer diameter is 12 millimeters. For modern diffs, or if you want to call them modern diffs, the diff outdrive has the same diameter from the cup all the way in, and that's a 10 millimeter diameter, which means if I were to try to put that in this gearbox, I would need to find a 10x12 bearing, and I can't find any 10x12 bearings other than like pin style one-way bearings. And I don't think I can get them of the correct size, like the correct width to fit in here. Even if I could, I'm not sure that I'd want to do it that way. I'd rather have a conventional bearing. So either I have to find somebody who 3D prints a Dynastorm gearbox with a 12 that can fit a 15 millimeter outer diameter bearing for the diff, so I can run a 10x15 bearing in with a modern diff in there, or I have to use the stock Dynastorm gearbox with the stock diff that will fit an 8x12 bearing. So for the time being, I'm going this route here, and what I decided to do is to bore out the openings here in the diff outdrive. If you go to my first video, I talked about how at least one of these outdrives had a significant notching in it that came from some kind of abuse from the previous user, I suppose. And what I essentially did is I took a Dremel with like one of those diamond type files essentially, and I just ground out a wider opening here on both sides on both outdrives. And what that allows me to do is to run this. So I can basically run pucks inside this outdrive. And this particular unit is for the Kyosho RB7SS with the Kyosho puck that goes in there, and it's a perfect fit. And it just so happens that the RB7SS dog bone length here from pin to pin is exactly the same size as what you have on the original Dynastorm. So this is actually a nice fit. This will also allow me to preserve at least this portion of the diff outdrive by running pucks. It's not going to really do any damage to this portion here, so I'm not going to get any more like chipping or anything like that, or divots. But I will still eventually wear out the splines. And these diff outdrives are very hard to find. They don't make these anymore. They're not compatible with TA02 units. They're a very different type of unit, even though those units do have splines. It's a completely different unit. So essentially, I'm going to run it this way until one of those breaks, and then I'll have to find a new solution. Hopefully somebody out there has a version of this gearbox that can fit a 10x15 bearing for a more modern diff. Until then, I just got to run it like this. Now, to try to help to preserve this more, obviously I have to run a slipper clutch, and the stock slipper clutch looks like this, with this weird-ass spur gear that mounts around this is essentially like a VTS-style slipper clutch, and it mounts around the outer housing of this. And if I strip this spur gear for any reason, I'm screwed, because you can't get these spur gears anymore. They're special Tamiya spur gears, and you can't. I mean, you could like take a modern spur gear and cut out the inside and drill holes to make it fit around this, but you'd have to cut it perfectly so that it doesn't wobble, like it's perfectly centered when you mount it. It is possible to do, but much more difficult than what I eventually settled on here. So before I got to this solution, I'll talk about some other things I tried. One thing that came to mind was the Kyosho slipper locker, or slipper lockout. This particular unit you would get on the RB7, and the way that this mates to the input shaft here, this input shaft has a notch on it. If I go here, you see this notch right here that has a 5mm diameter on the wide spot, and then the flat spot shrinks it down to about 4 or so. So it's almost like an ellipse, not quite, but almost like an ellipse. And this notch that's in here actually fits perfectly in that. So if I mounted it inside out, or yeah, I guess you could say inside out, this way it would slot right in, and the spur gear would be aligned in just the right way, so that it's sort of closer to the motor plate, so that you can fit, or you can have a pinion gear mounted on the motor and actually reach the spur gear. I didn't want a solution that pushed this thing so far out that the pinion and spur couldn't even get together. So this technically does work, but you lose your slipper. So I needed to find a slipper solution. What I eventually figured was, if I use, it could really be any part that's similar to this, but this is what I came across. Kyosho OL023. These are the slipper discs that are used in their Optima re-release, and I think also their Ultima re-release. These are steel, so they're kind of heavy compared to what you have on the RB6 and the RT6, which has similar slipper discs, but those are aluminum. They're lighter weight. I do have a set of those that I could use, but I don't want to ruin them if I have to modify them to fit onto this, because I'd like to keep those for my RBs and RTs. So in any case, I got these. All you have to do is shave out a little bit on the, and let me see if I can just get this out here, just to make it a little easier. You see, this has, there's a flat section and a rounded section. So you take those flat sections and you just shave out a little bit on either side, and then that'll slot right into the top shaft. That will go on the back side, okay? And then you take an associated style, or something like or a similar style spur gear that fits the octagon shaped slipper pads, and you just bore out the inside of that spur gear large enough so that you can fit a bearing in there. I went with a 5x9 bearing because that bearing is narrow enough to not get in the way of the slipper pads mounting onto the spur gear. If you bore it out to 5x10, the 5x10 bearing is a bit too wide. So you could do like a 5x8 or a 5x9 and just use like a reamer essentially to bore out the center hole, so you can slot that bearing right into the spur gear. That's the only modification you need to do to the spur gear. And if you use a reamer, you get a symmetric bore, so it's not like this thing's going to wobble around so much when you bore it out. And then in this case, I just happen to have a set of associated high torque slipper pads, put those on either side, and then I took another one of these plates here, okay, and I just threw it right on. For the outer plate, you don't have to do any modification, because the thickness of the inner plate plus the slipper pads plus the spur gear gets you to a point where you're already past this notch by the time this pad goes on. So even if you crank this thing all the way down, this particular pad isn't going to try to run into this notch here. And that's all I did. I kept the original spring and spacer units. I just added a few more spacers here. These are like little plastic spacers that slot right on, just to push this whole spring unit out, because this guy here is kind of thick. So when this mounts on, you have the right amount of length on the rest of the lay shaft to mount this spring. This unit here is much thinner, and so I need to pick up that extra space with something. I just happen to have some plastic spacers with a 4mm inner diameter that slot right on. If you have bushings, like metal bushings, you can do the same thing. Doesn't matter. So that's it. And this allows me to run modern 48-pitch spur gears with, modern slipper parts, if you will. There is a slight amount of wobble. It's ever so slight, because I had modified this for some other experiment, and I didn't do it perfectly symmetrically. But I think this will be okay enough that I can use it on this car. If not, I'll just throw another one on there. So that seems to work, and I will get going with the rest of the build. This is really what held me up the most in terms of figuring out what I was going to do about the drivetrain. Now that that's sorted, I can basically do the rest of the car. But again, if there's anybody out there who is working on a 3D printed redesign of this gearbox, I would highly recommend doing it in a way so that it can fit diff bearings with a 15mm outer diameter. Then you can run modern diffs in here, without having to deal with these diff out drives, which are impossible to find for the Dynastorm. Okay, so that's it for this update. Thanks for watching.